Hello. To explain the variation, the concept of the intuition behind the variation in a regression model, I do some quick graphs on PowerPoint. So it took about like 15 minutes. So let's think about simply x and y plane. X is the independent variable, explanatory variable, and y is the dependent variable. And there is a linear trend, linear relationship between y and x. You may think it like this: x is wage, and as I say, y is wage, and x is education. So the higher education you get, the more salary you are going to get. So the true relationship is by this much. And the straight line, can be characterized by two parameters, slope and intercept. So you may imagine something like this. So the true line can be written as y I equals to alpha plus beta xi. So this regression equation, this regression can be written in this way. So I have not considered the error term yet. So let me just write that down to prevent confusion. But the true line does not include error term epsilon. So anyhow, the slope is beta, and the intercept is alpha, and those two parameters represent one line, a straight line, in two-dimensional graph. And now suppose that you observe two observations. Of course, they have errors. So from the true relationship, some guy, there was an individual who was very unlucky. So he could not earn enough salary as much as he was educated. Relative to his expected salary, his salary was a little bit lower than the market price, say. But there was another guy who was very lucky. So given his education, he got more than expected salary. Anyhow, from these two observations, you would like to estimate the true slope, the effect of education on wage. Then what you do here is, in here, so these things are not observed. The only thing you observe is these 2 points. There's nothing. These are only the only thing what you observe. So you only have two observations. That's it. Of course, you don't know where is the true line, where is the how big is the errors. So these are all you have. And then, but still that's fine because you can estimate line going through these 2 points, right? So this is what you are doing basically, and the simplest possible concept. And then your estimated slope is given by the blue line. And when you compare the red and the blue, you can tell how big the estimation error is. So the estimation error arises because of the error term. So error happened this much, error happened, negative error here, positive error there. So your slope was, your estimation is on overestimation. It's too steep. So you are wrong, but there is no other way. Like you cannot avoid those errors as long as you got error terms. Here, what we are looking for here is, this is just basic intuition behind OLS estimation. It's nothing about variation at all. What I'm going to study here is, think about these 2 points. You have 2 points. on the left and on the right. But now consider the same situation, but now the only difference is that x is now similar to each other. The observed x's are similar to each other, so the variance in x is much smaller. However, I maintained the same amount of errors, so compare these errors to this. They are exactly the same because I copied and pasted. So the error size, epsilons, are the same, but the only difference is the distance between x, distance between those independent variables. So the variation in x is much smaller. And then do the same thing. This is your estimated slope, right? So also obvious what and estimation error is obvious, clearly much larger than what you had before. Compare this with this. So you see, even if the same amount of errors occur, still your estimation error is much larger when you have a smaller variation in x. So variation x is very important to make your estimation more stable, more accurate, right? So that's why variance of x is in the denominator, of the variance for the OLS estimator. That is the intuition. So having enough variation is important. For example, more practically, I said we are estimating the effect of education on wage. But suppose that in your data, there are only, say, college graduates and master graduates. So the difference between college graduates and master degree holders is like 1 year or 2 years. So the variation is very small. It's hard to tell the big picture, what happens outside. So ideally, you would like, if you could do an experiment on education, I would allocate people across all the possible education levels, from zero education, if possible, if experiment was possible, randomly choose some people and don't educate them at all, and some like others 1 year, others 2 years, and up to some people will be assigned to study for, let's say, 30 years, if possible. So that will be the ideal situation, but of course we cannot choose them. But you have to try your best to find large variation. Or if you think your estimator is not doing well, if your estimator is not accurate enough, if you think, then you may check the variation in x. The variation in x may cause some problem. Oh, for another example, I just came up with another example. If you want to study so for example, the effect of the difference between the wage difference between genders, male and female, the typical problem there is usually many data in the past had very small number of working women, right? Women's labor force participation was lower in the past, so most of the workers, employees' data were from men. So say if that means the variation is very small. So similarly, it is very difficult to estimate the effect of a very rare event. For example, what is the effect of having a criminal record? What happens if you were put in the jail for 10 years? Then what is the effect of that 10 years in jail on your future salary? The problem is, in the data, having 10 years in jail is really rare, so the variation is not sufficient. So most of people have never been in jail, so So your estimator will be very, very volatile, unreliable. Okay, that was an important intuition. So in the next video, I'm going back to the lecture slides.